Today we will discuss how remote sensing can be used for one of the important sector, that is agriculture. We all depend heavily on agriculture for food. So Indian agriculture is a backbone of economy and provide support to the livelihood of large number of people. Why we need agriculture remote sensing? But as I said, it is providing a livelihood support to the large number of people, and also liberalization and globalization. So overall, about 75% of people living in rural areas and are still dependent on agriculture. 43% of this Indian geographical area is for agriculture activity. Agriculture continue to play as a major role in Indian economy. So overall, you can see that agriculture not only contribute in economy, it generates large employment possibility. So see the status of Indian agriculture. Net sown area is around 139 million hectare, and what it support about food grain, almost in 2021, 308 million tons food grade production is from agriculture. Kharif around 149 and Rabi 159. At the same time, it also gives bumper horticulture production in fruit and vegetables around 331 million tons. Over the period of last 20-30 years, there has been tremendous increase in the irrigated area, and as of now, overall economic size, if you see in form of GDP, then agriculture contributes around 18% of GDP. Earlier, just you can see 20 years back, it was about contribution was about more than 35%. But nowadays, service sector and industrial sector has got larger share. But even though agriculture generate large scale employment opportunity, 55% people, mainly rural people, depend on agriculture. But basic problem in Indian agriculture with respect to monitoring of resources is mainly a field size, small field size. Small field size means less than around 1 hectare is our field size. Now, why it is a challenging Indian agriculture? Because there are large diversity of resources, or large diversity in terms of geographical setting with respect to the climatic design, soil types and physiography, as well as cropping system practiced. So if we see rainfall, there is a possibility of less than 250 mm rainfall in desert, up to 2000 mm rainfall in our Kashmir or Himachal Pradesh. So climate design ranging from arid to almost per humid. Similarly, soil types, there are loamy sand, gravelly soil, clay soil, as well lateritic soil. Many type of soil you will find, mainly in Indo-Gangetic plain, that is nearby. You can say whole Uttar Pradesh, Bihar, Bengal, this Rajasthan, Punjab, Haryana. Those is mainly alluvial plain, loamy sand, good soil. But there is in peninsula, you will find lateritic red soil. Similarly, physiography, large variation you will see. In India, you will find peninsula, you will find desert, you will find river terrace, you will find floodplain, alluvial plain, hills. Name any kind of landform you will find in India, because India, that is a very big landmass. So these all large scale of heterogeneity with respect to soil types and all this limit possibility of use of remote sensing data, even though we have many number of cropping system in practice also. All these have limiting little bit monitoring of the agriculture resource with the new technology, even though large number of application with the use of remote sensing data being realized for agriculture sector only. Around 65% of whatever application being carried out across India, it is mainly related to agriculture sector. So how this geospatial technology involving satellite remote sensing involves, it provides Earth observation data mainly from spaceborne as well as airborne. Spaceborne means satellite based, airborne means aerial images. There are various kind of resolution, partial, temporal and spectral resolution. Satellite data is available from very 1 meter resolution to almost 1 kilometer resolution. And all these satellite data, because of their different kind of resolution and spectral width, they enables monitoring of agriculture. Second, that is geographic information system, GIS. GIS is nothing but it is a kind of database system that helps to input, store, analyze, display partial and non-partial data. You can integrate any ground observation, you can integrate any aerial image, satellite image with the other network or in situ measurement and come out with a certain kind of decision making. So integration of all data can be possible within GIS. Third is a GNSS, Global Navigation System of System. So this system that enables you to identify the location. So in agriculture, mainly precision farming. How precision farming is possible? Only you have very good high resolution locational information is available. So that GPS can provide you a locational information, mobile mapping. Now with this GPS you can track. Mainly you can track, okay, if you are lost somewhere in forest area, something, you can use this GPS to identify and come back to your own location. Hello? बाद में hello. So these are the things which are there. GNS, location mapping. Then all these three together can help for the informed decision making. Informed decision making means you can integrate those data and finally helps farmer or policymaker to pass on information about whether okay when farmer has to sow their crop, what is the crop area, what are the acreage estimation, where in what stage farmer crops is there, whether it is a disease healthy crop or disease trace crop. All these decisions can be possible whether drought is affecting in a particular farm field or not. All these decisions possible with the integration of these three technologies. So in India, there are large number of satellites being launched in past. Today, as of now, operating satellite is ResourceSat 2 and ReSat 1. So ReSat is providing all weather capability. It is a active microwave satellite sensor. So whenever there is a cloud, mainly in rainy season, we need ReSat kind of data which available during cloudy period. Microwave backscatter information is collected to analyze rice crop. Because rice is one of the most staple crop in India. Second, this ResourceSat data that is mainly cannot penetrate through cloud. They are mainly used for Rabi crop monitoring. So there are various payload, mainly LEAS 3, LEAS 4 and the advanced LEAS. These all payloads helps in dynamic monitoring as well as explicitly partial mapping of different crop type distribution as well as monitoring. Along with this, there is some high resolution satellite data like Cartosat. Cartosat provides DEM. Cartosat provide DEM. So DEM is very much important for the soil terrain mapping. Similar, third is a ocean side satellite. Ocean side satellite is mainly useful for the ocean, but at the same time it provides some information like ocean color monitor, which helps to provide ocean NDVI, normalized different vegetation index, which is very much useful for the vegetation monitoring. Then there are weather related satellites, INSAT 3D, this SCATSAT, and also INSAT. All those provide weather related information that can be integrated with the land and water related information to make certain informed decisions related to agriculture. So as of now, we have capability to get the satellite image at a partial resolution of almost 1 meter to 1 kilometer at the different time interval. In India, there is an enormous potential of satellite remote sensing in agriculture, because India, yes, itself depends on agriculture for its livelihood. Remote sensing, particularly with respect to India, is one of the few countries which has made it possible to use satellite remote sensing for regular updation of agriculture statistics. So this timely information about this all help. Timely information about agriculture is vital for informed decision making and food security. Okay, so you can see here different kind of applications are there. Agriculture, there is a agriculture drought monitoring and assessment, horticulture crop assessment, cropping system analysis, agriculture land monitoring, fisheries. Nowadays, even this satellite data has been used for identifying the aquaculture and useful for aquaculture productivity, pest and disease monitoring, soil mapping, command area and irrigation monitoring. All these applications are very much useful for farmer as well as policymaker. Now let us see some satellite which are mainly Indian remote sensing satellite being used or has been used for last almost 2 decades for the various kind of agriculture application. So there is a one sensor list 4 on resource set with 5.6 meter resolution. Every 5 days it revisits the particular area, and there are almost 4 bands. So it is very much useful for field boundary detection, large small patches of the vegetable and horticulture crop. So it is high resolution mapping, it can be used. List 3, one of the versatile sensor for agriculture monitoring as well as agriculture crop type mapping, because it is having a 34 days temporal resolution with revisit capability. But one sensor, advanced WIPS, which is providing information every 5 days, 56 meter resolution, and has capability to dynamically monitor crop condition, agriculture drought, phenology, and many other things related to the crop yield forecasting. Apart from this optical satellite data, there is a synthetic aperture radar, SAR. It is a all-weather independent capability kind of satellite remote sensing. That is called microwave remote sensing. So that reset has got even C-band, but even though it has been widely used for rice crop monitoring. Rice is one of the most staple crop in India. So we have been using this SAR data mainly for operational rice crop monitoring. Then OCM, that is providing also 360 meter NDVI database, and it is also useful for agricultural drought monitoring. So let us understand how we can use these all satellite data what available with us for crop type mapping. So there is a basic fundamental thing is the interaction of the electromagnetic radiation with the object. Here in our case, object is a different kind of crop types. So once solar radiation is from the sun fall on the different kind of crop types, it interacts with the leaf color and this phenology, then also its color, shape, size, all those things. So after having interaction of electromagnetic radiation with the different crop types, some amount of energy reflected, absorbed and transmitted. So this reflected energy is being detected. Once these reflectors, different kind of crops, because of their different color, different size of leaf, phenology, their characteristic, other characteristic, crop cover, all those characteristics influence the magnitude of reflectors. So in different band, you will get different crop type has got different amount of reflectors. Here you see wheat crop, that is in NIR band, highest reflectors, followed by mustard crop. So sugarcane has the least reflectance in the near infrared range. Now why this? Because this is the curve obtained from the February end image of advanced wheat data. Now in the February end, wheat crop is in the peak growth stage, whereas mustard was about to just harvest, means it is in maturity stage, and sugarcane almost harvested. Only that small stem which is left for the regrowth as a ratoon crop is there. So when wheat is in the peak growth stage, it reflects more in case of NIR region. So reflectors is more in case of wheat. Mustard, only lower leaves are green, rest all are mature. So still little bit greenness is there, and cells wall is still not completely ruptured. So it is still okay reflecting in near infrared region. But sugarcane near infrared scattering is very less. So because of difference in this near infrared scattering by different crops, we could able to separate out all these three crops in the one single date image of advanced wheats. So basically, crop type identification is more concerned with the classifying all crop types from each other. Means it is very challenging task. Suppose it is in Gujarat or Maharashtra or some other region where there are more than 5 or 6 crops. You will find onion, you will find sunflower, you will find lotions of fodder crops, wheat crop as well as grapes, all in one hectare field. So it sometimes different kind of signature what you are getting is confused signature. Spectrally confusion will take place because all are not distinctly separable. So challenge is very much with the single date or some when multi-crop region is there. But acreage estimation is concerned with only a few target crops. That means suppose your interest is to have acreage estimation of only wheat crop in Bhopal district of Madhya Pradesh. Then what you will do? You will acquire satellite data, acquisition time of satellite data, as well as carrying out ground truth campaign and other research method, your methodology of acreage estimation. All you will focus with the wheat crop. So you will acquire satellite image which is best suited for wheat crop only. You will carry out ground truth when wheat crop is in the maximum growth stage, and also you will have a focus methodology and all other things which are ideally suited for the wheat crop. So you can improve the accuracy of wheat crop classification, and finally rest all other crops you can put as a non other crops. So it is a acreage estimation is quite easy, but crop discrimination of crop type identification is challenging task. So here you see one example with the boundary overlaying approach, because there are two approaches which has been used for classifying different crops. One is a boundary overlaying approach, another is a boundary overlaying approach, another is a this stratified sample segment approach. Boundary overlaying approach means for small area like tehsil, block or district administrative unit. You can have a boundary. That boundary you can use for masking the satellite image. After having mask with the administrative boundary, you can classify like, okay, this satellite data in form of FCC, we have mask. After masking, this image will be used for the classification with the ground truth information. Ground truth you identify and mark at the different places, training site. Based on that, then you use certain classification algorithm like MXL or minimum distance or any other advanced algorithm you can use also, random forest, ANN, anything. But finally, it will classify based on the ground truth training statistic what is the maximum likelihood possibility of particular pixel to be a part of the particular information class. So it is based on the maximum likelihood probability to be a member of particular information class. So after that, okay, we have to be able to classify. Now you see here 4 props are classified based on this boundary overlaying approach and MXL classifier. Similarly, in one part of Saharanpur district, nearby here Dehradun, we could able to classify even 2 variety, Basmati and the old variety, that traditional variety, Sarbati and traditional variety. Now question arises in your mind that can this, okay, list 3 kind of data helps to discriminate different variety? Then answer is no, because it is a unique signature only possible in the one this Beard block. When satellite image was available in the end of the October, there was a distinct signature because one variety was okay in the Solomon flowering stage, another is in stage of almost maturity. So both has got different kind of distinct appearance. As a result, we could be able to identify. But it may not be possible that everywhere, any region you can identify two variety. If by chance, okay, some good signature, identifiable signature you can get, then only you can do this classification up to variety level. Now here you see this crop, whole Haryana. That advanced with a single date we could able to get some 60 to 70 to 80% accuracy classification with sugarcane and mustard. But if you use, okay, little bit higher resolution data like list 3, which is used by Space Application Center, so you can get almost nearby or more than 90% accuracy with the traditional survey data, Bureau of Economic Survey, that district level estimate. So you can get with list 3 almost less error. But the moment we use advanced coarse resolution data, error is little bit higher. As I said, high resolution data, that all application I have shown earlier, that is a single date, only one date. But it is not possible to make classification in multi-crop region with a single date. Sometimes you need to make use of multi-date satellite data. So here in one project for sugarcane crop monitoring, we have used list 3 date, May, October and the February next year. 3 date satellite data, we have constructed profile, and based on profile, decision rules were made to classify. Here you can see this particularly in October image. It is very much possible to classify both planted ratoon and ratoon sugarcane crop, because ratoon sugarcane is almost you will find in the harvest almost harvesting stage. Harvested, but plant sugarcane will go up to even February. Which here you can see this is planted. Okay, it is here, okay, it is harvested February, but it is okay here you see growth is higher, but this is here growth is very less and also little bit harvested later, but this is harvested first. Now you see based on decision tree classifier, we have classified. Also, we have you make use of list 4 high resolution satellite data and compare how we will get the better accuracy for sugarcane crop type maybe. See the statistic here with the actual sugar mill, because sugar mill these days sugarcane information system is developed by the UP government. So they are having every sugarcane field is almost mapped with the GIS GPS survey. Now that GPS survey we have collected for that total cane area observed by the mill catchment, mill commissioner, and we have estimated with the satellite technology both list 4 and list 3 decision tree classifier. Now you see list 3 hardly okay, less than 1% error is there, but in case of here it is a 7% error. That means if you are having a more data, you can improve the classification accuracy even though satellite resolution is little bit poor. Here you see this is district level classification and this is ground based observation, where on ground it is a observation where there ratoon and plant sugarcane. This is a list 4 and similar ground based sugarcane field inventory with the GPS survey. So you can see this all pink is that is all sugarcane field. So we could, and yellow, pink and yellow. So we could able to classify little bit with the greater accuracy with both image segmentation as well as decision tree classifier. Now let's look at how we can make decision what kind of satellite data to be used, what kind of information they provide, what partial resolution data to be used for what at what level of mapping. So particularly in agriculture, suppose you need certain generalized where agriculture area is there. You can do it with even coarse resolution satellite data like OCM or earlier BIF data or MODIS data 250 meter resolution. You can make where agriculture is there. Because those all data are multi-temporal, almost less than weekly repeat you get. So you can based on the multi-day satellite data, you can easily map agriculture and other natural cover. So here you see rice and wheat both is mapped. This is wheat and rice is mapped. But state level you can use advanced SWIFT kind of satellite data. 60 meter resolution, you can map wheat, rice or some crop like that. Then district level, you can use these 3 kind of satellite resolution, 24 meter, 24 days repeat also. You can here you can get many number of classification will improve rice, cotton, 2 or 3 crops. Mandal level means block level, further you can go many crops with more higher resolution of 6 meters list 4. Even further that you can use even like quick bird space in that rapid eye and then world view. You can do even field level classification, 1 meter resolution kind of thing, 5 meter to 1 meter resolution. You can do cadastral level mapping of the different kind of crops. So it is depending upon the kind of resolution used your purpose. Cadastral levels, every field scale mapping of different kind of crops, we require very high resolution. These days, satellite is a foreign satellite like Sentinel, which is providing 10 meter partial resolution every weekly. So those kind of satellite, if it is weekly data is there, so you can do multi-day data along with the 10 meter, which is quite good partial resolution. So you can map even to certain extent mandal level mapping, easily possible. As I said, it is crop inventory not only possible with the optical data, because optical satellite, all those, they are not able to capture information from the ground during cloudy season. The cloud limitation is there, because this during cloudy season you will get the cloud contamination. But wherever there is cloud is there, you will get microwave remote sensing data like SAR. Using SAR, you can map rice or any crop which is cultivated during the rainy season. So here you can see basmati and old variety, non-basmati. With the multi-date data, this is 1, 2, 3, 4, 5, 6, 7 date satellite data we have used. Different parameter is there also, HS and VV polarization ratio, ratio vegetation index, alpha, all computed from the microwave back pattern in the different polarization. Now using this, we could able to classify non-basmati and basmati. Also, you can understand the stage how crop is developing. So with this, okay, multi-day data, you can acquire, get information about phenological stages, which crop growth stages, as well as the crop type. So here you can see we have used maize classification for multi-day data. Maize and bajra we could able to classify. So here additional polarimetric data if you use, like okay, that is dual polarimetry, full polarimetry, microwave remote sensing data is available. So if we use fully polarimetric data, accuracy will goes up beyond 80%. So here we have tried to make support vector machine, random forest and decision tree. These are all machine learning technique. With this machine learning technique, we could able to classify to certain extent, like okay, 60% or something like okay, maize accuracy. Overall, bajra, that is also okay, even 40% accuracy. So this is still in research phase, because with the microwave remote sensing and its utilization for the acreage estimation of the coarse millet like maize, sorghum, bajra, it is still in the research and development stage. So for this operational monitoring of agriculture, we have one institute that is called Mahalanobis National Crop Forecast Center. Now this center is mandated to provide regular update on crop statistic at district level and state level. At state level, they are going to give with the advanced risk data. At district level, almost for the more than 15 crops. Right now, this center is giving up every season, Kharif and Rabi both, acreage estimation of these all crop, rice, wheat, mustard, jute, cotton, sugarcane, potash, sorghum. Even many more crops are also added in this for regular operational crop acreage estimation as well as monitoring. So this is the program called FASL, forecasting agriculture output using space, agrometeorology and the land observation. Here why, okay, we are only space that can provide information. Space, we need to develop connection with the ground. So ground observation is always required. Also, agriculture is taking place under open sky. When any activity which is under open sky, then weather has got a main role to play. So weather determines the season of the crop, weather determines the condition of the crop also. So if we integrate weather along with the observation, then we could able to monitor agriculture nicely with the space along with the weather and agrometeorology and the land observation. Apart from this crop acreage, crop condition monitoring is an essential component and part of the monitoring agriculture. Like how we can monitor crop disease, infestation, insect pest damage, crop stress like nutrient or salinity, disaster damage like flood, drought, hailstorm. How this all can be mapped, because these are the very important conditions which affect the crop performance and finally affect the crop yield. So there are various kind of techniques, remote sensing based technology being developed to detect crop traces either from disease pest, nutrient or drought or hailstorm. For drought, we try to understand how drought we can map or detect. Once okay, rainfall occur, so water falls on the ground, it infiltrates, some is lost as runoff. Once it is infiltrated and recharge the soil water root zone, this water is being taken up by the roots. It moves via xylem to the leaves. From leaves, There are tiny pores called stomata. From stomata, water exists as a transpiration, evapotranspiration. Once this water molecule exists, then it provides space for carbon dioxide to fix. So new photosynthesis process will start. Once photosynthesis process will start, then new assimilation, dry matter will get assimilated, new leaves will come. Once these new leaves form, it is detected by the satellite sensor. Now you think, when rainfall occur, it was occur 2 or 3 weeks back, but detected by the satellite sensor after 2 weeks. So that is called time lag. So satellite has got capability to monitor agriculture drought, but with certain kind of time lag, mainly with the optical approach. If you use some thermal approach like directly, which estimate directly evapotranspiration and can provide you some indicator of drought. There are also sphere-based wavelength, which is also even highly sensitive to the directly the change in the leaf water status. So it can also provide early estimate of drought. But this optical NDVI based approach, that is a not falls short for the real-time drought monitoring. So there are data like NOAA, daily image is available. Terra Modis also you can get daily, twice a day. Indian satellite, earlier it was a WIPS, nowadays it is a advanced WIPS. Resource set also advanced WIPS sensor is there, 56-meter resolution, 5 days. So this advanced WIPS is mainly useful for the district level, the state level. All those NOAA, Terra Modis is being used, or from all these satellite, NDVI is being computed and used on a weekly basis or fortnightly basis for monitoring agriculture drought, mainly the drought impacted vegetation condition. So here you see what is the stress vegetation, how it appear in the electromagnetic spectrum, spectral curve. If there is a healthy vegetation, what will happen? Healthy vegetation means good photosynthesis, chlorophyll concentration is more, so more absorption of this wavelength, visible wavelength. So as a result, its reflectance is less. But in NIR, if cell wall is healthy, its base scatter in NIR region is more, because there is multiple scattering it take place at the cell wall interface. So healthy cell wall, healthy structure, more scattering. If it is a stress vegetation, this cell wall get ruptured. As a result, scattering may not take place. So reflectance will goes down. Another 3 is a water absorption band. Here water absorption, because water thickness in the leaves. If plant has got more water containing leaves, absorption of this wavelength will move more compared to the stress vegetation. So here you will find 3 dips. All this region helps to form different kind of vegetation indices for drought monitoring. So here you see how NDVI can be useful. Healthy vegetation, more base scattering, least visible reflectors like less than 0.08, more scattering more than 50%. NDVI value will get around more than 0.7. For stress vegetation, more reflectors in visible, NDVI will be less than 0.2. So stress vegetation index value goes down, mainly NDVI, and pure vegetation means healthy vegetation will always find above 0.7. So how this approach is being evolved for the agriculture drought monitoring with the satellite remote sensing, because it is not only the optical satellite data. There are many satellite which data are satellite available, which operate in the different orbit to provide vital space observation to help monitoring agriculture as well as agriculture drought. So like for rainfall and weather related observation, there are geostationary satellite, rain gauge, IMD, India Meteorological Department, some observatory data is there, automatic weather station. Because drought, agriculture drought means inadequacy of soil moisture in the root zone. So we need to monitor fluctuation in the soil moisture. That is only possible with the soil water balance technique, in situ measurement. Apart from that, microwave remote sensing satellite data, which has got capability to provide soil moisture. Nowadays, also even we can use thermal data to sense evapotranspiration and as an indicator of drought. Then crop condition, as I said, optical data, mainly NDVI, long-term NDVI or SWSI, which short wave based vegetation index, all are useful for crop condition assessment. To certain extent, we will get crop sown area also. Crop sown, how much crop sown area deviation is there from slope angle index. So all these four together helps to decide drought and declare drought severity at the district level. Here you see what are the sensors are being used. We have got one program called NADAMS, National Agriculture Drought Assessment and Monitoring System. It was being developed at National Remote Sensing Center. Now it is operationally being done by the Mahalanobis National Crop Forecast Center, MNCFs. So different data like ResourceSat, NOAA, OceanSat, OCN, TerraModis, INSET, all data to use to generate different kind of vegetation index, this slope angles NSS index. It is very much useful to identify sown area discrimination. Wetness will get from this microwave remote sensing data like MSRE or other kind of data to get surface wetness. Crop condition mainly from NDVI, also this crop condition also from other satellite also. All three, which NDVI, moisture, slope, snow cover area, also NDWI, all are used to derive drought impacted vegetation condition index and finally drought characterization. Some studies, okay, a lot of progress has been done with respect to agriculture drought assessment, mainly from meteorological drought indicator, geopartially also being developed, also remote sensing indicator. Many studies, many newer and newer indices has been developed either okay and alone or as a combined index. So like vegetation condition index, vegetation drought index, combined drought index, many index are nowadays being developed with a satellite based measure to derive to depict agriculture drought. Drought prediction level also people have tried to INSO linkage or space-time relationship or some Markov model. All has been used for nowadays technique has been used or people have been developing to how to forecast drought. So crop specific drought monitoring is very much essential because finally we have to compensate the farmer based on the how much crop loss is there. You cannot equate different crops. Certain crops are very much sensitive to the drought. Certain crop may be okay and not resistant to the drought. So alone simple agriculture drought assessment may not serve purpose unless and until we can get crop specific drought loss, crop damage due to crop specific condition. Okay, so crop specific drought monitoring is a need of our. That can be possible also to certain kind of indicator like water requirement satisfaction index. If we compute for each and every crop, that surely help for the early warning as well as indicator of crop specific drought. Some modeling approach can be also tried like crop simulation model for drought monitoring. So here you can see 2002 almost 2003. This is a normal, means all blue you see that NDVI anomaly index is positive. That means it is normal. But 2002, you can see this is all yellow. All is less than negative anomaly. NDVI anomaly is negative. That means 2002, all months were under drought. From June to almost October. But in case of 2000, only first 2 months, June and July, they were under drought. So slight drought, normal, severe drought, normal, all different category in Rajasthan. This is one Rajasthan state. We could able to depict with the satellite remote sensing. That or seasonal, if you integrate, that can serve as a index for the crop loss detection also. You can see here, seasonal vegetation anomaly index is highly related with the food grain yield anomaly of Rajasthan. So whenever drought is there, food grain yield anomaly is very much negative. Whenever means more than okay, you can see 70-80% food gain is lost. But when this above normal year is there, then it is a positive, like 2003, 2001, 2003. So one combined index, one example is a vegetation condition index, the temperature condition index, and combining both these things, we can compute vegetation health. So vegetation health is one of the good indicator because it takes care of both temperature condition as well as vegetation condition. Because vegetation is a highly product or process resultant from the soil moisture fluctuation, highly sensitive to soil moisture. But at the same time, temperature is equally important. Temperature regulates the reproductive process, maturity, grain formation, flowering, all those kind of stages highly sensitive to the temperature. So unless we do not take into account both temperature and the soil moisture related sensitivity, then we could not correctly capture the effect of drought on the crop performance. That is why vegetation health is maybe the good indicator for the this. So here you see one example of Saurashtra in Gujarat. You see 2002 all is red. That means stress. All weekly they are in stress. In 2000 next year only all is green. That means there was favorable condition, no drought condition in there. And this can be also seen in the graph crop moisture index from ground observation of the agromet observatory, mainly potential evapotranspiration, and this crop moisture index is nothing but the extent to which crop water requirement can be met. So this crop moisture index, you see, this is negative, huh? Mostly always less than 0. Most of the week it is a less than 0. That means crop moisture index is negative. That means there is a drought. But here you see all is above 0. Mostly it is above 0 crop moisture index. So there is no drought most of the week. Similarly in eastern Rajasthan, you see little bit more severe drought compared to Gujarat. All is above, okay, you can see more than 0 mostly, and here also above. And this all can be useful for the monitoring vegetation. You can combine to get the VCI, TCI, and finally you can estimate vegetation health. And these indicators are useful for identifying the crop yield loss. How much crop yield loss is there? Relationship you can get VCI against the crop yield in the case of Gujarat. So that is about what methodologies exist in India with respect to the agriculture drought. But recently there was a requirement from the ministry to make a new drought manual, which is at par complied with across the state. So Ministry of Agriculture along with our MNCFC and other all stakeholders come out with the new drought monitoring guidelines. So as per these guidelines, there are 3 indicators is identified, 3 trigger. Trigger 1, that is mainly based on the rainfall or standardized precipitation index. Because what IMD is monitoring, IMD is doing only deviation in the percentile rainfall or you can say standardized precipitation index. This is a deviation in rainfall, accumulated rainfall, or you can say particular month rainfall. Standardized deviation in particular month rainfall or this 3-month rainfall. Suppose we are doing for the August, then it is a standardized deviation in the month of rainfall, accumulated rainfall of the August month and previous 2 months in comparison to the normal. So that is called SPI, the standardized precipitation index. So these are useful indicators for deriving whether there is a drought is there or not. Once confirmed, then we go to the second criteria, that is done with the remote sensing. Crop situation means area under sowing, all those things. Soil moisture varieties based on soil moisture maps, either from water balance or from satellite. Percent available soil moisture, moisture adequacy index. Fourth is the groundwater. groundwater pumping, irrigation resources, groundwater developed drought index, or remote sensing this rainfall severity index. All hydrological related variable is used to find out. Out of 4 criteria, 3 criteria is used to define the drought, second trigger, whether it is a severe drought or moderate drought. If 3 out of 4 3 criteria meet the severe drought category, then you can classify in particular area is a severe drought category. You can reduce this severe drought category to moderate drought category based on the third approach called verification. If you can go to the ground, identify on the ground whether crop condition is so much affected or not. If you find okay there is not much effect on the ground, then you can reduce that classified output of severe category to the moderate category. That is all about ground verification that ground staff or patwari and those people can do. So assessment is that first trigger mainly SPI and rainfall deviation. Then remote sensing data mainly soil moisture. Then crop condition, soil moisture, hydrological performance mainly groundwater and other things. Crop zone area. Out of three category is severe, then it is severe, and 2 then moderate. Okay, then based on ground verification, finally we declare whether it is severe or moderate category of drought occurs in the particular area. So this is a new manual which has been practiced nowadays. Many states has implemented online. They are all those who don't have access to information, they can visit MNCFC site, where you can get all this NDI data set. You can get rainfall data set for your district, and you can do this kind of drought, developing this kind of drought monitoring and finally drought indicator. Another hailstorm also affect. Like hailstorm, it is a affecting like balls, ice ball. It's a falling because of sudden change in the inversion process, atmospheric inversion. So as a result, you will find certain kind of hailstorm. Hailstorm are the ice ball which are impacting on the ground. As a result, it will directly affect the canopy. The canopy lodging, crop lodging, or crop will get damaged. So we could able to do this with the list 4 data. This is one village in the Nara village in the Meerut district, nearby here Delhi. So in October, we have got once before this hailstorm and after hailstorm. Now here you see these all were the good crop. Red you are seeing that was the good crop, potato crop. But just because of this hailstorm, all damaged. This bluish tinges you are seeing, that crop is all damaged. Not this. This is a urban area, village, but crop is damaged. This all is a crop damage there. And this we could able to see NDVI. NDVI is higher. This is before this, after this damage. NDVI has gone down like anything. Crop is damaged. This we could able to identify and detect that more slightly affected, moderately affected. This based on the we could able to map different category of the affected category of potato crop due to hailstorm. The high resolution data. Last then there is a crop yield estimation also. We can nowadays it can be one basic source of information is a remote sensing data. Crop yield is nothing but crop production per unit area. This is called crop productivity. And crop productivity depends on weather, crop, soil, and agronomic management. And it is imposes great challenge for the modelers. It is very difficult to model crop productivity. But quality of remote sensing data and its unique characteristic like large area coverage, multispectral observation, dynamic frequent repetitivity. All these characteristics makes it possible to acquire observation. At the times, we can relate it with the ground crop performance. Crop productivity is very much useful for food security related policy decisions like import, export, minimum support price, and other crop management aspects. Like today, based on the crop production forecast only, policymaker or government can take decision about whether a particular commodity has to be imported or exported. Also, minimum support price. Nowadays, 24 crops are covered under minimum support price, and government release this minimum support price based on the one or every year what is the situation of the crop production of particular crop. So this, if we have got advanced forecast, then it helps the policymaker to decide or make decision related to import, export, some crop planning, crop management aspect, and minimum support price. There are different kind of approach: statistical, spectral VI based approach, spectral profile phenology based approach, deterministic biomass production based approach, and integration of crop model. So here you see, this is simple statistical approach where we can acquire satellite image, NDI is computed once we have classified wheat crop. So only those pixels related belonging to wheat crop, that wheat crop NDI is extracted. The wheat crop NDI at different site where we have got some crop cutting experiment with the track that NDI of wheat crop and develop certain kind of regression, linear regression or multivariate regression. So here you see students are harvesting wheat crop 1 by 1 kilometer, and they will do threshing, and they do threshing and finally grain. So this is a kind of activity which is going on. Here, see here there are different kind of things there. Like these are the all crop cutting experiment. 1, 2, 3, 4. We are seeing these are all crop cutting experiment. Then this is one NDI image. Then crop, this is classified FCC Saharanpur. That is FCC list 4 data is classified as a different crop type like wheat, sugarcane, orchard, and other crop cover. So this is Saharanpur district town. Then after classification, only wheat related NDI of only wheat crop. Then that NDI is related with the yield, crop cutting based yield. We get certain 43-45% relations fit. So it is not halfway. But the moment we can include soil related factor, somewhere you can say 55%. Further, if we take management, we can further improve model up to 70%. So it is all about because crop yield is not simply biomass. NDVI and this optical based indices which we get from the satellite data, also backscatter from remote sensing, microwave remote sensing, or other data. They are better related with the biomass. Yield, economic produce, that is yield, which is also dependent on the soil factor as a management factor as well as weather factor. So unless until we do not take care about all those things, we cannot get the better yield model for the crop yield estimation well in advance. Even though we could able to develop model NDI, land productivity index, and irrigation frequency to forecast estimate yield in Saharanpur with a quite reasonable accuracy. Error is around 5.33 quintal per hectare. If we consider here 35 or 40 quintal per hectare, so around we can say 15% error is there, 80 to 80. So another is phenology based model. Phenology means timing of occurrence of different event in response to the life cycle of organism. So here occurrence of different stages in the crop growth, in response to abiotic factor. Timing of occurrence of different phases of crop in response to abiotic factor. So abiotic factor means temperature, soil, water, like that. So here you see, this is start of growth. Emergence will take place. Crop reach to the peak growth stage. This is an NDVI curve. Whole year, every weekly. So here you see, this is start. Then it is started. Then crop reach to the peak growth stage. Then okay, crop is started maturing senescence, and it is okay, almost harvested. So this is called length of growing season. This is a peak NDVI, then peak time, then okay, this is okay, amplitude. So these are the different phenological parameters. These phenological parameters derived and related with the crop yield to get the crop yield model. So here you can see we have developed cotton lint yield model with the peak NDVI, amplitude and length of growing season to forecast cotton yield. So these are the peak NDVI values, length of growing season, amplitude based on the time series analysis. This is not simple. You have to apply certain time series program like Selsky Gole or some smoothing curve smoothing or three curvy linear feet. Then you can get the parameter of those Badwar profile also. You can get the parameter of those and finally relate with the yield to get the relations. Another is a semi-empirical physical model. This all most of we understood that radiation, sunlight is important for the crop growth. Sunlight is important for photosynthesis activity in case of plant. That how plant make food, only use of sunlight. That sunlight is converted into a biomass and finally it is multiplied with harvest index to get the yield. That is called efficiency based approach. Here you see wheat area is there. For every pixel that wheat NDVI is there. Photosynthetically active radiation, which is sunlight. The sunlight, okay, we multiply with the fraction of absorbed photosynthetic active radiation, you will get total absorbed photosynthetic active radiation for 8 days, multiply with the light use efficiency, means dry matter or biomass produced per unit of this absorbed photosynthetic active radiation utilized. That is called light use efficiency. Multiply APR into light use efficiency, you will get the NPP or you can say biomass for every 8 days. When you make total summation of the biomass for every day 8 days biomass from emergence to harvest, you will get the total biomass. Then total biomass multiply with the harvest index. Harvest index means nothing but economical yield to the biological yield, which is around 0.35 for the wheat crop. So you will get finally the yield. Now you see this is a yield image for one approach, another approach. You see most of the district within 10% estimate is there, you could able to forecast. Fourth is irrigation water management is also one of the important with respect to the agriculture. When to irrigate, how much to irrigate, where to irrigate. This kind of decision not possible only with the advanced technology like UAV, unmanned aerial vehicle or hyperspectral remote sensing. So we need to monitor water status, we need to monitor plant canopy status, we need to monitor the crop evapotranspiration status. So how we can map crop evapotranspiration? Particularly crop water requirement is nothing but it is the maximum amount of water which is required by any crop to meet the evapotranspiration losses and metabolic losses. That is called crop water requirement. Traditionally, all agriculturists or university people, agriculture, they are using observatory data, mainly radiation, temperature, humidity, wind speed. They use those data to compute ET0, means reference evapotranspiration. Multiply by the reference crop, they get reference evapotranspiration. But it is possible to make use of this approach with the remote sensing. Mainly potential evapotranspiration nowadays possible to get estimate from the geostationary satellite data like INSET 3DR, INSET VISA, many SAVIRI, many foreign satellites are also there geostationary. You can make daily evapotranspiration, potential evapotranspiration map or reference evapotranspiration map. Then crop factor you can get from the NDVI. Nowadays we are having the NDVI almost on a daily basis. Like okay, Sentinel weekly available. Then also Modi's course resolution satellite. We are having a NDVI data set every daily basis. So you can use those kind of data to get the NDVI and some observation you use to get the crop coefficient. So crop coefficient is nothing but it is the ratio of actual evapotranspiration to the reference evapotranspiration, means ET divided by ET0. So how we have done, like meteorological data, okay, if you don't have satellite data, there are methods are there, empirical method which can use helps you to estimate reference evapotranspiration, like PN1 Menteith, Planicidal, many are there. Then you do some geostatistical interpolation to get ET0 map. Advanced data you can use for crop classification. Modi's data you can use for the NDVI generation. Then with ground observation of lysimeter data, crop coefficient, you relate against the NDVI to get the some exponential and negative curve of Kc to get the crop coefficient, and finally crop coefficient multiply with the reference evapotranspiration to get the crop water requirement. So here you can see this okay whole area from November to almost April. How it is okay, you see now wheat crop has emerged. Green. You see greening, that means wheat crop has emerged, reached to the peak growth stage. Here it is achieving most of the area is green. So wheat crop has reached to the peak growth stage. Then after okay harvesting started, maturity started from March onwards, and it become yellow, and then okay finally harvested. So you will find this kind of curve. Crop growing, reach to the peak and then harvested. Different district of Haryana. We have developed this exponential model with the Kc against the NDVI. Then finally crop coefficient for every week is estimated. Multiply with the ET0 to get the crop water requirement for different stages. And finally the total water requirement of the different district in Haryana. You can see majority of district having a crop water requirement between 290 mm to 350 mm. If you take 50 mm as a one irrigation, so it will come around 6 to 7 irrigation. Mostly 6 to 7 irrigation is required across the 5 to 7 irrigation is required across the Haryana to meet the water requirement of the wheat crop. Another important is the hyperspectral imaging, advanced technology now gaining importance. So multispectral, microwave, all we have talked. Now new era is the hyperspectral imaging, because hyperspectral that can enables you to detect different causes of stress. Till today, what we have seen, hailstorm damage, drought stress, all those things. That is stress. Whether it is because of what nutrient, whether it is because of paste, whether it is because of disease, or whether it is because of temperature, we cannot figure out with the multispectral remote sensing. For that, we need to have a very high hyper spectral resolution data. 10 nanoband, 10 narrowband indices we require. So 10 nanometer wavelength based hyperspectral data from 0.4 means 40 to almost 2500 nanometer wavelength range we require, and those all bands, more than 200 bands, provide you a unique absorption and reflectors information to ascertain various kind of crop related stresses. So we can do stress, yield mapping, soil contamination, but multispectral only give crop anomalies, crop performance, crop pieces. So here basic difference is that only few bands, but they are sensitive only to plant anatomical changes. Means appearance, organ size, how you appear, plant appear from outwards, canopy cover, plant size, or outward appearance. But this hyperspectral, it can be sensitive to biochemical composition as well as plant physiological changes. So inert biochemistry as well as plant physiology is altered because of different kind of stress, and which is possible to detect with the hyperspectral remote sensing. So UAV, nowadays all UAV, we are talking about unmanned aerial vehicle or drone. So this drone has made game changer. Now government of India is pushing drone technology to monitor crop growth, crop, to map different land record, to predict predictive analytics of the yield, crop insurance activities, name any activity, precision farming. So all the new dimension in agriculture will be provided by the not only artificial intelligence, other thing. All artificial intelligence and new technology require drone application also. So AI, drone, robotic agriculture, and all those, they are going to be a game changer with respect to the not only agricultural water management, but integrated nutrient management, for disease forecasting, pest forecasting, all will may be possible with the latest technology. So thermal camera, if it is there on board, we can get surface temperature, which can be useful further for the evapotranspiration, crop water stress detection, every field level also. You can assess crop water stress detection and other things with the UAV. So overall, India, globally, there are large number of applications being realized. If we see climate change also nowadays, okay, we are making, because nowadays worldwide, no HR, Modi's, we have got history of satellite data. Historical archives are available for more than 20 years. So the 20 or 30 years of satellite data were available. Those can be used as a to identify the indicator of climate change. So nowadays, remote sensing data are going to provide a tremendous input for the understanding Earth observation signal for the climate change. Then land use land cover change, cropland mapping, crop type mapping, all can be possible. A different kind of satellite data with Indian remote sensing as well as coarse resolution satellite data, microwave remote sensing data, other foreign satellite data, all has got tremendous application in the future also. So that is all about this. Okay, what I want to say, but in India, there are different kind of program is going on. One is a coordinated program on horticulture crop assessment called Chaman. So which deals with the horticulture crop assessment and production monitoring. Either potato, apple, all vegetable crops, all covered under the Chaman. Then there is a Kisan crop insurance using space technology and geoinformatics. Under that, because of pest and disease, cyclonic, hailstorm damage assessment, or any crop water stress, all those because of stress and this heavy rain, off-seasonal rain, you can go in this program. GIS, GPS, drone, high resolution satellite data, along with the systematically planned crop cutting experiment are being used to define, detect, or develop crop insurance index, remote sensing based insurance index for adjusting the crop compensation or better assessment of the crop compensation. Then there is the agro means मौसम सेवा, ग्रामीण कृषि मौसम सेवा, agromet advisory service. Okay, course resolution satellite data like INSET or rainfall estimate available from various course resolution satellite data. All are being used for the monitoring of crop condition as well as okay soil suitability and when to show crop, what is the status of crop, whether soil moisture is higher or less, when to irrigate, all those kind of decision at the block level. Information about agromet advisory is given under this program. So future will be mainly integrating all drone field techniques, new artificial intelligence, remote sensing, satellites, and observation. All will pave a way for the systematic and accurate monitoring of the crop performance and finally informed decision related to the crop management by the farmers will be a reality. Thank you all.